Okay, let's do this problem. I want to make sure you get my viewpoint on this problem. This is the standard dosing problem. There's a lot of ways to do dosing problems. I like to attack them from this dimensional analysis, these conversion factors methods that we've been talking about all semester. It can help me because I don't need to have a formula. I don't need to memorize 30 applications. I can figure my way out using the units. So I see I need to give a patient 50 milliliters of Chemex, that using a 35% by volume Chemex solution. How many milliliters of solution should I inject? Immediately, I really want to stop and think about what is this? I know they're talking about a solution. They're telling me Chemex solution. And a solution, by definition, as soon as I see solution, I'm knowing it's a mixture of two things. So what is this? I know it has a solute and a solvent. I know that one of them is Chemex. It doesn't tell me the other. Chances are, if it doesn't tell me the other, it's going to be water. The fact that it tells me 35% by volume Chemex solution means that the solute is Chemex. That's huge. I need to identify the solute in this because what's going on is I want to administer just the solute, but I can get it from a mixture. So I'm going to have to give that, inject some water or whatever the solvent is, along with what I read the actual chemical that I want to give to them. So I'm going to have to figure out how much more solution I'm going to need since it's not pure Chemex. So immediately I see two numbers, 50 milliliters Chemex, and again, we figured out that Chemex is a solute. And it's really important to be thinking about what is the solute, what is the solvent. I'm talking about the solution. Solute and solution are going to be very important in these problems. I also know 35% by volume. So that would also be BV, would be another way of saying by volume. Chemex solution. And as soon as I see that, I start thinking percents are conversion factors. So I'm going to turn this into a conversion factor. I know that 35% means 35 over 100. And by definition, if we look up the equation for percent, whether it's percent mass, percent volume, or percent mass by volume, it's always solute. The first unit is volume, and that's going to be of the solute. It's always solute on top, and it's always solution on bottom. In this case, it says B and B, so I need a unit that's going to be a volume unit for both. So let's say 35 milliliters of solute per 100 milliliters of solution. In this case, it's going to be more useful, instead of using the word solute, let me write for this particular problem, the solute is Chemex. So I'm going to write that this solution has 35 milliliters of Chemex per 100 milliliters of solution. Note, this is a conversion factor. It's telling me I can use this as a conversion factor, and all conversion factors are considered to be equivalent on the top and bottom. It's saying 100 milliliters of solution is equivalent to 35 milliliters of solute. The other milliliters would be the solvent. So I can flip it if I need to. I'm putting both up. I don't know which one I'm going to need. Remember, I do not want to start my problem with my conversion factor. I want to start my problem with the other number, the number that only has one unit. If it has two units, I want to hold off on it. So the other number is the 50 milliliters Chemex. I'm going to start with that. 50 milliliters Chemex. And then go back to my problem. They're asking me for milliliters of solution. I'm just going to kind of write milliliters solution over here on the right to keep track of. That's what I'm trying to find. So I'm looking for something, and I know for sure that I have to find some kind of conversion factor with milliliters of Chemex on the bottom. Well, I have two to choose from. The fact that I took the time and wrote them out, I have two to choose from. And it looks like the one that would cancel out milliliters of Chemex is this one. So I'm going to use that one. 35 milliliters Chemex, 100 milliliters solution. And note that when I do that, I end up with milliliter solution, which is exactly what I want. So it's basically, that's all I need to do. 50 times 100, divide by 35, and I'll get my answer. 500 divided by 35, see what that is. .28. That's got to be wrong. Oh, 50 times 100 is 5,000. 50 times 100 divide by 35. And I get 1571. Try that again. Can't use my calculator today. Okay, 142.8 milliliters of solution. Now that makes sense. I want just the solute should be just 50, but I'm going to give them a solution. So I'm expecting my answer should be bigger than 50. 50 is the solute by itself. This is the solute along with the solvent in a solution. So I'm expecting this number to be bigger, and it is. So in this case, I'd probably round that off to 140 milliliters of solution. So I'm going to inject 140 milliliters of solution. The patient's going to get some of the solvent in there with it, and then they're going to get out of this solvent 50 milliliters of the solute. This is generally how we're going to work all of these problems. I can use molarity as a conversion factor. So if I said 5.0 molar Chemex solution, if instead of using a 35% by volume Chemex solution, I'm using a 5.0 molar Chemex solution, I could still come up with this as being 5.0 moles. Again, molarity is moles of solute. In this case, the solute is Chemex per 1 liter of solution. Because molarity is defined as the moles of solute per liter of solution. So the only part that's, I have to figure out what the solute is, and I have to look at what is the molarity to determine this number on the top. The rest of it should be remaining the same. I can flip that if I need to. Note how important it is for me to write the actual solute and solution when I'm writing this, because that's the thing that's going to cancel out. Did the problem start with telling me how much solute I want, or did it start with telling me how much solution I have? I have to look at the context to decide, am I want this conversion factor or do I need to flip it? And with that strategy, you can do all of the dosing problems. You can try 14 and 17. 17 is a little tricky, but it's asking you to find how many grams of solute from the first solution, and then if I use another solution, how much of that solution how many milliliters of solution would I need to get the same grams of solute? So 16, 14 are both very much like this. Good luck.